Okay, I think it's a couple of minutes past 1, so I suggest we get started. So, am I going through all right? I hope so.
Yeah, we
Samantha,
can
can
hear
you just
you.
confirm? Very
We can
good.
hear
Excellent.
you.
Okay. Excellent. Okay. Well, hello. My name is Up. Beginning. That was a little bit of a technical hiccup from the beginning, so that's ironic. But my name is Halfdan Lynge, and I'm a senior lecturer at the Wits School of Governance, where I teach quantitative methods and political economy. I'm also the founder and non-executive director of Sauti, which is a data science company specialized in crowdsourcing and the use of mobile technology in crowdsourcing. And we work with governments, civil society organizations, private enterprises that we help them either mine their existing data, analyze existing data, or we help them collect new data using mobile technology. So that's a way of reducing the cost of data collection, which can be quite expensive. Let me see if this slides. If you're interested in getting in touch or want to hear more about my work, you can either find me on the website of the Wits School of Governance, where you can read about my research, which sort of broadly explores the effect of digitization on public policy and governance. You can also check out the website of Sauti if you want to read more about the platform. So we built a technological platform that allows us to collect public opinion data in Mozambique. If you're interested in learning more about that, you can go to this website here. Obviously, if you're on social media, you can also find me on Twitter. I'm not super active on Twitter. I generally I tweet mainly about sort of tech and application of tech in the public sector, but I end up often sort of more speaking about football and ranting when my favorite team loses, which unfortunately happens quite often. Finally, I just want to, if you are interested in tech and data science, I just want to highlight this website, which is the Civic Tech Innovation Network. Which was recently moved to the Wits School of Governance. So it's now hosted at the Wits School of Governance. I do some work with the Civic Tech Innovation Network, but if you're interested in learning more about it, you should get in touch with Geshe Karuri Sabina, who is the national organizer of the CTIN, or Civic Tech Innovation Network. And she's also a visiting research fellow at the Wits School of Governance. Okay, so today I'll be talking about data science and the application of data science in public policy, meaning data-driven decision-making in the public sector. So I'll be speaking mainly as an academic, but I will draw on my experience, my past experiences, both as a civil servant and also as an entrepreneur, someone who has worked in this sort of data science tech space in the private sector. So I'll try to draw on those experiences and link it to academic research and academic literature. So essentially, I want to do 3 things in this presentation. The first thing is I want to highlight some trends, some current trends in data science. If you are already familiar with, if you're already interested in data science and the tech space, most of this will not be surprising, but I think it's important to provide some context and point to some of the dynamics, some of the processes that really are affecting everything we do. It's affecting the public sector, the private sector, but I want to link that specifically to public policy. So basically reflect on these trends, identify the trends, and then reflect on these trends in light of public policy. Finally, I want to point to some of the things that we need to change if we are to use data science for public good. So right now we have sort of these broad trends, and it's obvious that these broad trends will affect public policy. But what is it then we need to do as society to fully utilize, take advantage of the opportunities that are provided by the availability of data and technology and data science? So I also want to use the opportunity to first give a couple of examples where data science has been used for public policy. I'll focus on two examples. I mean, there's a lot out there, but I want to focus on two examples and really try to sort of walk you through, start with the problem analysis and then take you through how technology was used to solve a problem. And finally, in all of this, I'm hoping, but we'll see how far we get. I'm hoping that I can also use this talk to demystify certain concepts in data science. I think one of the biggest problems about this space is that was very fashionable, and there's a lot of fancy words out there that you know, we constantly hear, we're constantly presented with these ideas and concepts. But I realize that very often people don't fully understand what they mean, or they think they know, but in actual fact, they haven't fully understood. So I'll try to focus on 3-4 sort of key concepts in data science, or data science techniques that are common and that will be even more common in the future. Okay, so in 2017, The Economist, the weekly newspaper, The Economist, published this this cover page and a special report about the data economy. In short, the argument was that in the 21st century, data would become what oil was in the 20th century. So really sort of the driver of growth and change. Although this edition and this special report was not, it didn't really tell us anything we didn't know, but it seemed that it was a little bit of a wake-up call for a lot of people, both in private and the public sector, that to see the potential in data and data science and then fully start exploiting the potential here. So I said I wanted to highlight 3 trends in data science that in different ways are affecting public policy processes and public governance. So again, if you are familiar with this space, if you're already reading a lot about it, none of this will be surprising, but I just want to make sure we're on the same page here. So the first trend is really fairly obvious. Data volumes are increasing. We have an incredible amount of data available to us, and it's growing all the time. Now, you probably know this, but I just want to put into perspective how fast data volumes are increasing. So this chart here shows the annual size of, they call it the global data sphere. So essentially the amount of data that is produced every year. The amount of data that's produced every year. And I'm not sure how accurate it is because it's based on a lot of assumptions and a lot of estimates, and different reports have come up with different figures. But this is the most recent one. I think this report was from 2018, and it's the most recent estimate that I could find. The one thing you should notice here is that the increase is exponential. So it increases with a relatively fixed percent every year. That percent has been estimated anywhere from 40 to 65%. So the amount of data we produce as societies increase, let's say 40 to 65% every year. This means that by 2025, we are going to have approximately 100, or we will produce approximately 175 zettabytes. Now, obviously, most people don't know what a zettabyte is because it's an incredibly large number, but I just wanted to put it into perspective a little bit. So what is 175 zettabytes? Well, first of all, just to understand the number, 175 zettabytes is 175 followed by 21 zeros of bytes, okay? So it's an incredibly big number. You all have an idea of what a DVD is and how much information you can store on a DVD. 175 zettabytes is the equivalent of 23 stacks of DVDs reaching from Earth to the moon, okay? So it's an incredibly large number. If we were to download all of this data, again, we are just talking about the production of data per year. If we wanted to download all of this data, it would take approximately 4.5 billion years if we were on a sort of a regular 10 megabits fiber to the home connection, so 4.5 billion years. One of the reasons why the amount of data is growing so quickly is that our ability to store data and the cost of data storage has dropped enormously. So this graphic shows you, some of you who are my age will remember these 8-inch floppy disks. So they were introduced back in the 70s, and they had a maximum capacity of approximately 1.2 megabytes. And it was quite expensive to store data using those floppy disks. The estimate here is 1,000 pounds. That would be probably 20,000 rand back in the 70s. But if you look at the graphic, you can then see that these very old school floppy disks that I remember from my childhood were replaced by smaller 5.5-inch floppy disk, followed by USB drive, memory cards of different sizes and shapes, and eventually the cloud. The key point here is that if you see the lower line here, that the cost of saving information has dropped enormously. Again, from around 20,000 rand back in the 70s per gigabyte back in the 70s, we're now at a point where it's less, let's say it's less than a rand per gigabyte. And often with these cloud services, we'll often get a lot of storage capacity for free. So if you register for Dropbox or anything similar, you would often get a relatively large amount for free just by registering. So because it is cheap to store data, it also means that it's not costly for us. One thing is collecting the data, but another thing is actually then storing it for later use. And these two trends combined mean that the total volume of data is really increasing. So that's the first trend. The second trend is that the nature of data is changing. We tend to, so I just have to follow my notes here. We tend to think of data as sort of Excel spreadsheets, sort of a simple database where you have observations in lines and you have different variables in column, which is like the typical structure of an Excel spreadsheet. This is what we call structured data, where there's a clear structure in a data set. But in fact, most data today is not structured, okay? It is what we call unstructured. So that would be photos, text files, video files, audio files, social media sites, web pages and blog posts, etc., etc. All of this is potential data, but it doesn't have an immediately recognizable structure in it. In fact, often this data is collected not intentionally, but it is just a byproduct of something else we're doing. And that's why we sometimes call this unstructured data, data exhaust. So that would be data from mobile phones, from mobile networks, data from financial transactions. Every time you swipe your credit card, there's some kind of record somewhere. So all of that is potentially data, but it is not data in the form of an Excel spreadsheet. It is just large amounts of unstructured data where there's no obvious connection between the data points. At least it's not obviously visible. So this is just to show that unstructured data is really, most data today is in the form of unstructured data. Around 70 to 90% of all, remember I showed you the graph before with the increase in data, around 70 to 90% of all of this data is what we call unstructured data, okay? And unstructured, the amount of unstructured data that we collect increases much faster than the amount of structured data. In fact, there are people who believe, or there are estimates that we actually collect less structured data now than we did a couple of years ago. And the reason for that is that we have all of this data exhaust. We are already collecting all this unstructured data. And because of our ability to use this unstructured data, there's really no need for collecting all of this structured data. But the point here is that the structure of data is changing, and it is unstructured data, most of what we are collecting. The second graph just shows you that the increase of real-time data, collection of real-time data. So back in 2010, it was an estimated 10% of the data we collect, and according to this estimate, in 2025, it'll be close to half of all the data that we collect will be real-time data, okay? Okay, so that was the first two trends. The last trend would be processing power, and the fact that our processing power is improving constantly. Some of you may have heard about Moore's law, and Moore's law is essentially the observation that the number of transistors in an integrated circle doubles every 2 years. Okay, so this is really engineering talk for saying that the speed with which we can process data. So remember, processing refers to the speed with which a computer can complete computations and how fast it can analyze data. That speed approximately doubles every 2 years, okay? So if you look at this, and we don't need to go into the details, but I just want to flag one thing here. So when you look at this graph here, it appears that there's some kind of a linear relationship, but pay attention to the y-axis here, that it's exponential, right? So it's not, it's an exponential relationship, the same way that the amount of data that we're collecting is also increasing exponentially. Bottom line is that our ability not only to collect data, not only are we collecting more data than ever before, but we're also able to process, to analyze all of this data. Because again, as I write here, more processing power means more analytical capacity, okay? The more processing power, the quicker we can analyze data, the quicker we can learn from the data. So what does all of this mean for policy making? In public policy, it's quite common to talk about a policy process or a policy making cycle. So to identify certain steps in which we develop, implement, and monitor the implementation of policy. So it starts, and again, those of you who are doing public policy or have done public policy classes, you will probably have seen different versions of this one, and you know, in public policy there can be a lot of discussions about, you know, what is the actual number of steps and what is the actual sequencing, etc., etc. It's not really important here. Just keep in mind that there is a policy process that starts with problem identification and some kind of agenda setting, it's called here, which is really like a public debate around policy issue. That leads into a policy formulation stage where we actually develop our policies, and of course these policies have to go through a democratic process and have to be approved. Then we start implementing policies, and once we've implemented, we then evaluate the implementation, or evaluate the policies to determine the success of these policies. And of course, then the conclusions of that will lead into a new cycle of policy. I want to highlight, I'm not going to go through all of the different steps of the policy cycle, but I just want to highlight a couple of ways in which the availability of data, our ability to process data, affects this policy cycle. So if we start with the agenda setting. And remember, agenda setting also includes sort of public discourse, public debate around priorities, and, you know, what's more important, how should we allocate resources, how should we invest our time and energy, etc., as collectives, as societies. So historically, of course, the media, traditional media, has played an important role in setting these agenda. And as you probably also know, social media is becoming increasingly important, and there's a lot of research that documents that. So one way that we can use data science to understand this agenda setting process or public debate is through something, text mining, and something called web scraping. It's essentially a way of, and I'll show you a little figure afterwards to try to explain what it is, but essentially we can use text mining and web scraping as a way of tracking public opinion almost real time. So again, as I said in the beginning, I want to use this this little presentation also as an opportunity to demystify a couple of concepts. So the first one, I call them footnotes, and the first footnote here is what is web scraping, and some of you might have heard of it before, but essentially it's just a technique that allows us to look through a lot of data, unstructured data, on the internet and somehow try to make sense of it. So you will develop little applications that can look through different websites and collect text, and then using these text mining techniques and try to make sense of it, try to cluster it, try to identify themes. So this is a way, web scraping is a way we can understand what's going on constantly on the internet and understand some of the ideas, the views that are shaped out in this virtual space. Now, just want to point out here that obviously there's a lot of potential here, and as I said before, potentially we can create almost a real-time monitor, or we can perform almost real-time monitoring of public opinion. And it has been developed. We have seen examples, for example, in Hong Kong, they developed a platform that allowed them to track public opinion. But obviously, there's a little bit of a caveat here, because as you know, social media users do not represent the population. They have a different demographic profile. Typically, they're younger and perhaps more outspoken, and also within different social media platforms, we also develop these subcultures and norms that are not necessarily reflection of reality. So if we try to say something about public opinion purely on the basis of social media, we'll get a little bit of a distorted view. But it is a possibility. It can be done. It has been done. But obviously, the output of these technologies will have to be interpreted cautiously and put into perspective. Yeah, I'm just highlighting here that social media use, and this is based on research, that social media users tend to pay attention to the short-term drama, sort of the short-term news cycle, rather than the long-term boring policies around social issues or economic issues. Perhaps economics is the one that people are least interested in, perhaps also because it's complex, it's technical, and not easy to understand. Okay, so that's on agenda setting. On policy formulation. So again, I'm moving through the policy cycle here, and I'm moving on to the next step, which is policy formulation. In the policy formulation phase, often policy makers face this dilemma between responding quickly to something or waiting for evidence. And I mean, we are now in a situation where, or perhaps a couple of months ago, it was more pronounced that governments all over the world suddenly had to respond to a new situation, a new reality. And they were faced with this dilemma of, do we do something now? Or do we try to fully understand what's going on and try to develop the perfect response to the pandemic? And that's a dilemma. And we saw how different countries adopted different approaches. The availability of data, again, the three trends, the availability of data and our ability to process all of this data essentially allows policymakers to do both of it. They can respond quickly, and by responding quickly, they also generate information, they generate data that allows them to optimize the policy response. Sorry, I'm just... So first, the availability of data and our ability to process this data means that there's probably evidence already out there. And this evidence that already exists, remember, we have this big repository of data already existing. And often a lot of this data can be used to simulate interventions already. Okay, and I'll try to illustrate this. So later on, I'll give a couple of examples. But because we have data already, we have a lot of data already, we can use this data to estimate, to predict, to forecast, to simulate the effect of different policies. So this again draws on massive databases and sophisticated data science techniques. Another thing we can do is using a different type of statistical analysis or data science analysis. So the policy environments that we work in are extremely complex. Okay, in those of you who have done statistics courses will know what I'm talking about. I say there's a lot of independent variables. There are so many different things that affect our policy space and that can therefore shape the outcome of our policy interventions. Unlike more traditional statistical techniques, machine learning specifically can handle all of these variables. It can estimate effects in these, I call them multidimensional spaces, and therefore provide better descriptions of the real world. Okay, so all of a sudden we are not talking sort of one-on-one statistics where you learn how to do a regression analysis, identify independent variable and identify the dependent variables, and then run a regression. We are talking big multi-dimensional spaces, and machine learning allows us to take into consideration all of these different variables, their possible interactions, and while taking that into consideration, estimating some kind of effect of a policy intervention. It sounds technical, but later on I'll give a couple of examples and hopefully it gets more concrete then. This should be footnote number 2 about machine learning. So what is machine learning? And I think the easiest way to try to explain it is just consisting of 2 steps. And this here's focus. We make a distinction between supervised and unsupervised machine learning. These are, you don't have to worry about that for now, but let's just try to look at this little visualization here. So imagine we have pictures of cats and dogs. I don't know how clear it is, but these ones are supposed to be dogs and these ones are supposed to be cats. Okay. So we have pictures of cats and dogs, and we feed those pictures into a machine without giving it any information. Using machine learning, we are then able to differentiate cats from dogs, simply because the machine is able to identify the differences. It doesn't know what a cat is, it doesn't know what a dog is, but purely on the differences of these pictures, the machine can separate all of these pictures into 2 different groups. So that's a way of thinking of machine learning. And as I said before, we talk about supervised machine learning and unsupervised machine learning. The supervised machine learning would be if we actually tell the machine that here's a picture of a cat, here's a picture of a dog, here's 1,000 pictures of cats and dogs. Try to identify, based on what I've told you, try to identify the cats and dogs. So that would be the supervised machine learning. Unsupervised is a situation where we just give a machine 1,000 pictures of cats and dogs and tell the machine, separate all these pictures into 2 different categories. And because cats and dogs don't look alike, and the machine will be able to identify that because of the shape of the face or the distance between the eyes, etc., the machine can split all of these pictures up into 2 groups. So this is a way of thinking of machine learning. It's a very simplified way, and machine learning really, it covers a broad spectrum of data science techniques, and it's too complex and technical to go into it here, but I just wanted to give you some kind of intuitive understanding of what machine learning is. I think a lot of people tend to think machine learning is like robots, same as when we talk about artificial intelligence, people have perhaps little distorted ideas of what it actually means. Machine learning just means a type of data science that we can use to analyze data that we don't know, where there's no obvious structure. We don't really know what we are looking for here, but machine learning allows us to identify correlations and patterns in this kind of data. So this was a footnote, a very long footnote. I apologize for that, but I just wanted to make sure we have some shared understanding of what this means. So again, moving on through the policy cycle here. So we've now gone through agenda setting, policy formulation, and we assume that these policies have been adopted, and we're now at the implementation stage. Because of the data landscape, the data environment we live in, policy implementation will almost always and immediately generate new data, okay? Simply by implementing, simply through our administrative bureaucratic procedures, we are generating data. It's probably not structured data, it's probably unstructured, but there is data, and we can use this data to generate knowledge and learn more. So it becomes almost sort of a real-time monitoring of our policy implementation. Even in those cases, and I said before, most policy implementation generates data. It might just be a trail of public servants who are responsible for implementing decisions. But even in cases where there's no data trail, data exhaust from policy implementation, we can use existing data to monitor the implementation or to monitor the effect of our policies. And I'll give a couple of examples here. So during the pandemic, for example, mobile data was used to predict the spread of the virus and monitor the effect of social distancing measures, right? Mobile phone companies constantly know where we are. I mean, if you have a smartphone, they know it extremely precisely because there's a GPS transmitter in the smartphone. But even with sort of old school second generation GSM Nokia phones, because your phone will constantly connect to a cell tower, mobile network operators know where you move around. And because the virus spreads with people, if you know how people move around, if you can predict the patterns in which people move around, you can also predict how the virus will spread. And because you can constantly monitor people's movements and interactions, you can also real-time monitor the effect of different social distancing measures, which means policymakers can, if they're facing a dilemma, they're faced with two different options. They can try, there's a policy intervention A and a policy intervention B. If they don't know which one is the right policy, they can try policy intervention A, see how it affects our social behavior, see how it affects the way we move around. And then in another area, they can try policy B and track that as well. So it gives them this opportunity of testing different policies, monitoring the effect of these policies real time, and taking a decision on the right policy approach. So this was on how mobile data, which is constantly produced. Another example that was also used during the pandemic was on using Google search histories to see how right here to determine how to allocate scarce resources. And it's because if in the middle of a pandemic you suddenly start searching for how to treat a fever or how to treat a dry cough, well, it doesn't mean you've caught the virus, but the probability or the risk of you having caught it is certainly higher than if you are not Googling, searching for this. So using these search histories, we can first of all, we can also predict the spread of the virus, or we can track the spread of the virus, but we can also identify areas where we previously didn't know that the virus has spread. And we can use that information to allocate scarce resources to say, well, if we only have a limited number of hospital beds, well, then just try to move it towards area A rather than towards area B. So it's just to give you examples of how even when policy implementation does not generate data, because we have all of this data out there, we can still monitor, in most cases, we can still monitor the effect of the implementation of public policies. So now we have moved around and we are now at the policy evaluation stage. So in the traditional policy cycle, evaluation typically happens at the end, okay? This means that we rarely exit a policy. We rarely give up a policy unless the negative effects, the negative unintended consequences are obvious, okay? It has to be extremely obvious for us to abandon a policy. And usually we don't do that until, because we spend so much time developing these policies. So we give it a chance to, we give ourselves a chance to implement these policies before we then assess the effect of it. Because of this immediate data generation and our capacity to process this data and monitor implementation real time, it means that a lot of evaluation results become available already during the policy implementation. And this, I already alluded to it before, this allows policymakers to adopt more of a trial and error approach to public policy without, and I say here, without inflating the human and financial costs, right? Because they can test a policy and they can abandon a policy quite quickly if they realize that the policy is not working as intended, right? So we are not, by piloting an alternative or an innovative creative policy, we are not risking a whole lot simply because we will, if it's not working, we will be able to identify it quickly, and we will be able to abandon that policy quite quickly as well. And I write here that then the policy making becomes, rather than this sort of cyclical linear structure, it becomes an iterative process where we constantly keep refining policies, right? So we have this sort of constant back and forth in all steps of the policy making cycle. We will have information that allows us to optimize each step before we move on to the next. So it sort of generates a completely different view of what policymaking looked like, and we can constantly update our policies and refine our policies until we reach some kind of imagined optimum here. And yes, the conclusion of that, of course, is that we need to start thinking differently about policy cycle. So this is obviously an oil tanker, and I'm using it just to illustrate that traditionally policy making has been almost like changing policy has been almost like changing direction of an oil tanker, right? It requires a lot of time, a lot of energy, a lot of resources to change course, right? Whereas with data and with data science, all of a sudden we can test things much quicker and we can change course much quicker. So we are not, just because we've chosen one path, it doesn't mean we can't change it. We are not stuck with that path. We can see how it goes and we can make constant adjustment and changes to the course that we've chosen. So coming back, I said we probably need to reconsider the way we see a policymaking cycle. And I tend to think of it as, you know, the policies, again, the policy cycle has this sort of linear logic to it. But because we have these constant feedback loops through data, through the availability of data and our ability to process the data, we're constantly getting information about what's going on. So there's these like constant feedback loops in the process that allows us to make constant adjustments. And because of these feedback loops, it allows us to be more creative and innovative and daring in our public policies, because the costs are not that high. We can try things out, and if it doesn't work, it's not the end of the world. We will know immediately, and we can make these immediate adjustments to it. So I know I'm probably running a little bit over time, but I just wanted to give you a couple of examples here. Two examples. One is from Togo, and this is because, again, I think a lot of these concepts are a little bit abstract. So I wanted to show you two examples of where data science has been used for for public policy, and more specifically data generation and this sort of real-time monitoring. So the first example is from Togo. And as you know, during the pandemic, governments all over the world had to distribute sort of emergency relief, emergency aid. But obviously, when they can't, I mean, as in the case of Togo, there's a limited amount of resources available. So the question is, who do they help first? Who is most in need? The Togolese government doesn't, and certainly didn't, have good data available. Existing data registries are out of date, and because most people work in the informal sector, which means they're not filing tax returns, so it's really difficult to say anything about or identify low-income households other than just sort of broad categories, broad areas. We don't really know. And obviously, it's difficult to collect additional data in the middle of a pandemic. So the solution for the Togolese government was to integrate, and I'll show you what this means. So they integrated household survey data with satellite imagery and merging that data, and then used deep learning. Deep learning is also a type of machine learning. They use deep learning to analyze and understand patterns in this data. They didn't have capacity to do that, so they partnered with these two, the Center for Effective Global Action and the Data Intensive Development Lab, which is both research centers at Berkeley University in San Francisco. So they provided the know-how and capacity, and then helped the Togolese government to implement this solution. So again, another footnote here quickly on what is deep learning. So I spoke before about machine learning, where you have some kind of input, meaning data, and based on this data, you try to understand what's going on, you classify the data, and you create an output. Deep learning actually, you don't really have to do anything. Deep learning will itself see the structure of a data set. So you are not even providing any information, any guiding. Using deep learning algorithms, you can identify patterns in something where you have no idea what you're looking for. So think of it as a sort of a sub-discipline within machine learning. So again, I'll try to explain what the Togolese government did. So this is just a neighborhood in Lomé, the capital of Togo. And suppose they have household survey data. So for certain households in an area, they have a lot of information. They've already collected survey data from a while ago, and so they have information about these specific households. So for example, suppose they know the household income level of these households. By merging, remember, by merging or sort of integrating household data with satellite imagery, all of a sudden they don't just know how much, they don't just know the household income. All of a sudden they also know the size, because with satellite imagery, you can estimate the size of the house. You can estimate, for example, the roof material. So all of a sudden they have additional information. They don't just have survey information for household survey information, that they have additional information they can extract from a satellite imagery. Household size, the roof material. They also know distances, and I'm just using the example here. They would be able to estimate the distance from a specific household to the nearest school. Okay, so we are now merging two different data sets, and all of a sudden we have a lot more information about the same households. Now, I'm highlighting here, this is a different household, and this household, imagine this household was not included in the household survey, so we don't know what the income is, what the household income of this house here. We don't know because the house was not included in the survey. However, we do know, because this house is captured by a satellite image, we do know what the size of the house is, and we are able to estimate the type of material the roof is made of. And we also know with distance to the nearest school. So by using deep learning and exploring the correlates of this massive data set we all of a sudden have, we then, based on the correlations between all of these variables, we can actually estimate the household income purely on the basis of the correlations. Because we have some household where we know both the sort of satellite, the information provided by satellite imagery, and we have the household. And based on that, we can develop a model that can predict household income based on things we can see in a satellite image. And with that model, we can then all of a sudden start making predictions of household incomes all over the city, all over the country. So it's and the Togolese government was then, not only were they allowed, by using this, by merging these types of data and using sophisticated data science, they were able not only to respond quickly to the pandemic, but they also, as a byproduct, they also developed this extremely fine-grained measure of poverty that they can use to monitor the effect of other interventions, simply because they are able to model household incomes based on satellite imagery. And there's a satellite crossing Togo probably every half an hour or every hour, which means you almost have a real-time a way of monitoring poverty levels real time, and you can constantly track changes because it is captured by satellite imagery. We're probably running out of time, but I wanted to give you also an example of Mozambique. So in Mozambique, price data, so information about prices and inflation is collected only in three cities. Maputo, Beira, and Nampula, and I'll try to illustrate where they are located in the country. So we only have price data information from these three urban centers, and because of that, we basically don't know anything about what's happening in the rural areas, although the vast majority, 2/3 of the population live in the rural areas, okay? We only know about inflation in the urban centers, although the population live in the rural areas. Because of that, it's extremely difficult for the Mozambican government and the central bank to adjust its fiscal and monetary policies because they don't have information. They don't know what's going on with prices, price fluctuations outside of the big cities. So yeah, this is just a picture to illustrate how inflation data is actually collected. This specific image is from the census. So this is actually an enumerator from the census in 2017. But essentially the process of collecting price data in Mozambique is very similar to this here. They are actual people who will go to markets and collect information about price items, food items. And obviously this makes it extremely slow and expensive to collect data because you have to train people, you have to deploy them, you have to send them out there, and you have to, typically they will collect information, then you have to process all of that information. So it makes it slow and expensive to collect price data. And also there's, because it's expensive, the sample sizes are relatively small, and there's obviously always possibility of human error, and all of this increases the risk of bias or just getting bad data. So the solution for the Mozambican government here was to try to use crowdsourcing. And it had to be crowdsourcing based on very simplified mobile technology, simply because in Mozambique, most people, 90% of the population don't have access to internet. They don't have smartphones. They're still using old school 2G GSM mobile technology. So I say we, so this is Sauti, the company that I'm still involved with as a founder and non-executive director. So together with the UN in Mozambique, we approached the Mozambican government and proposed a solution to this problem that draws on second generation mobile technology and crowdsourcing techniques. And we were able to partner with the two largest mobile network operators who basically allowed us to use their infrastructure and their network for free. So it was part of their corporate social responsibility that they allowed us to use their networks for data collection. Footnote again on crowdsourcing. What is crowdsourcing? So first of all, crowdsourcing is not a data science technique per se, but it's also something that we talk a lot about. So what is crowdsourcing? A quick example here. Obviously this is a cow. And the question is, how much does this cow weigh? Most of us don't know. We don't know how much a cow weighs. But on average, together, we actually know. Because some of us will overestimate how much a cow weighs and others will underestimate it. But because of this, on average, the average of all of our estimates will be very close to the actual weight of the cow. And actually, NPR, National Public Radio in the US, actually ran an experiment where they asked, I think it was 17,000 people how much a cow weighs, and they provided a picture of it. And as you can see here, so this is the distribution of the responses. And you can see the average was I can't even see what it is there. But bottom line is that the average of these 17,000 people who didn't know anything about cows or how much a cow weighed, the average of their guesses was very close to the mean. And this is really the logic of crowdsourcing. The fact that I don't know, you don't know, probably most people don't know, but on average, because we are all able to make some kind of informed guess, on average, we probably come very close to the mean. So we wanted to use this technique to collect price data in Mozambique, acknowledging that we don't always know the prices of items, and there's a lot of variation, but on average, collectively, we can estimate the price of different items. So what we're doing is to send SMSs out to a random sample of people, inviting them to submit price data. So we'll send out SMSs asking them, for example, how much they pay for one egg. So these are just SMSs going out. People can then submit price information through what's called a USSD channel. And a USSD channel, again, it's a simplified mobile technology that you can access even using basic standard Nokia phones by entering a short code that activates a little menu. And people can then provide information about how much they pay, in this case, how much they pay for an egg. And we get all of this information through mobile phones. In exchange for, so as an incentive and in exchange for their submission, the respondents then receive an airtime voucher, and it's to encourage participation. They also get information about prices in their area. So there's an additional way of creating an incentive to participate in this. So this is just the platform as it looks like. It's not launched yet. It will be launched on the 1st of October, and then it will run for an initial period of 6 months as a pilot. But if successful, it will really provide the Mozambican government with high frequency, sort of disaggregated price data, including in the rural areas where they currently don't have enough, a lot of information. And that will allow them to respond much quicker, adjust fiscal and monetary policies much quicker when in cases of a shock, for example, such as the pandemic. I wanted to say a little bit more about what it takes to implement some of this. Perhaps we can just quickly run through it because I see we only have a couple of minutes left. I want to highlight 3 things here, and I'll try to do it quickly. The first thing is really, so what is it we need to do? Well, first of all, we need to train the next generation of policymakers, okay? What we're talking about here is fairly complex, because data science in itself is the integration of computer science and applied statistics. And if you add a third dimension to it, we're now talking computer science, applied statistics, and public policy. No one, and certainly no one has all of these skills, okay? Which means we need to bring together people from these different fields. And if those of you who work in the public sector probably know how difficult it is to bring together people from different departments. You know, the people in your IT department, they think everyone is stupid because they don't know how to install software. The people in the research, the statisticians, the economists who work in the research departments don't understand why people are not listening to them and feel that, you know, politicians are just there to make their life difficult. And at the same time, you have, you know, the sectoral specialists who are like passionate and committed to their specific field. We need to get these people to work together. And that is extremely difficult because they come from different backgrounds. They have a different approach to it. They think differently about and they feel, you know, their little field is the most important thing in the world. So I think one of the biggest challenges is to give everyone a shared basis, shared language, shared understanding, and understand what each of these fields will add. And that means that, for example, it means that a public policy specialist, you know, that even the students that come out of the School of Governance, if you ask me, the next generation of public servants, they really need to have not only, I mean, we are already giving them basic understanding of applied statistics, but in addition to that, they should have a very basic understanding of computer science. So not because they need to be special and not because they're designing the systems themselves, but they need to be able to understand what the computer scientists are saying. So how we bring all of these, how we equip all of these people to work together and how we push them, how we incentivize their collaboration is probably the biggest challenge. A second thing we really need to do is to make data available. And this image here, this picture here is from the Johannesburg Botanical Gardens. And the reason I'm using this example is that in economic terms, so in economics, there's a concept around a public good. Public good is something that it's characterized by three things. So it has high upfront cost and low marginal cost, okay? So it's often things that are very expensive to build or create, but once it is built, it is relatively cheap to use, right? So it's expensive to create a park, but once it's there, we can all use it. A second characteristic of public good is that it's non-rivalrous, okay? So that means that if I use that good, it doesn't deplete. You know, multiple people can use the same good at the same time, right? So even if I visit Johannesburg Botanical Gardens and use that public good, it doesn't mean other people cannot go there at the same time. Finally, public goods have externalities. And here we tend to focus on negative externalities, but we forget that often there's also positive externalities, and that's particularly the case with data. When multiple data sets can be combined, that would be considered externalities. When multiple data sets can be combined, it means new information, new knowledge is created. Because, and I showed you the example before when we took household data and satellite imagery, merged it, and we learned something from that. That is only possible because household information, household data was available and satellite imagery was available. Imagine all of this was not available. Then we wouldn't have been able to merge the data set and learn more. So that is really a big challenge. Make data available. And I've made, in another forum, I've made an argument around treating data as a public good, that we should actually start seeing private data as a public good instead of just thinking of privacy and protecting it. And, you know, tech companies treat their data as an asset. We should treat it as a public good. We should invest public money in data to allow everyone to have access to the data. Of course, there are privacy issues that have to be respected, but instead of holding on to it, we should make data available because it allows everyone to participate in innovation and creation of new things. Yeah, this is just a link to the argument. Finally, the last thing we need to do is to develop shared standards and infrastructure, because one thing is having data available, but we also need to have the platforms and the infrastructure that allows us to combine these data sets. So if data set A is developed according to one set of norms and data set B is developed according to another set of norms, it becomes almost impossible to integrate these things. So that's another important area where we need to sort of state intervention to allow all of these different components to speak together, because it's the only way we can actually learn from data. So I wanted to couple of questions, and then they're really just for future reflection because we need to wrap up here. There are lots of issues, and I've highlighted a lot of issues here, but I just wanted to sort of summarize some of the first question here is it really possible to make the necessary legal and administrative changes? Because we need to rethink, if we are rethinking the policy cycle at a theoretical level. It also means we need to rethink the bureaucratic and legal administrative procedures within government to adjust to fully take advantage of these possibilities that data and data science provide. Are we willing to invest the necessary resources? I said before, we need to invest in developing shared standards and infrastructure, but of course that costs money. And if we spend money on this, we can spend it elsewhere. Again, I've already spoken a lot about it. How do we equip the next generation of policymakers and public servants? They need to have a different skill sets. And I'm not convinced that the skills we are giving, that we are currently giving to the next generation of public servants is what they will need in the future. They will need to have a better understanding of data, of data science, and the links to computer science and their specific field of expertise, public policy expertise. Is there a way we can, so I made an argument for treating private data as a public good, but obviously that creates a problem because we are effectively disincentivizing investments in the data economy. If you're a private firm, why would you invest in the data economy if what you produce, the data, is not yours? I've made suggestions as to how this could be addressed through licensing or something similar. So it's not impossible. It is something we need to think about. Obviously, there are issues around privacy. How do we protect privacy while, how do we make data available, including personal private data, while still protecting privacy? It can be done, and there's a lot of, again, techniques, data science techniques that we can use to protect the identity of people while still making extremely fine-grained data available. We don't have time to go into that, but there are ways of doing it. Finally, how do we ensure algorithmic transparency and accountability? And this is really a problem that is becoming increasingly apparent, that, you know, if we push responsibility away and say, well, you know, I didn't take a decision, this solution came up through some kind of algorithm, it also raises questions around who is responsible for the decision. If policymakers can sort of protect themselves or cover themselves by referring to some concept or algorithm, surely they are still responsible. So those are issues around the policymaking process and sort of public accountability frameworks that we need to consider when data science becomes fully integrated in our processes, public policy processes. Last bit here, I just want to, if you're interested in this, I just want to flag 3 books here that I find particularly helpful. They're very, although some of this stuff is complex, they're very easy to read and give a good introduction to data science. The first one is just a general introduction to big data and data science, not specifically public policy, but it gives you a good understanding of some of these technologies and techniques. Second one is on crowdsourcing specifically. And the last one is a more critical book, which exactly points to these what of this technology and using algorithms to solve public policy problems. That's it. I'm really sorry for taking this long. I even had to skip a couple of things. I wasn't sure how long it would take. I can see a couple of questions. If we have a few more minutes, I'll try to address them. First question is about, did the SA government get the COVID-related data wrong? Overestimation of numbers of expected infections or deaths and underestimation of socioeconomic impact. I'm afraid I'm not the right person because I don't have enough information, but I do know from other countries that there was a lot of difficulty simply in collecting information. So there was a big delay in the processing collection of data. So in a lot of countries, governments were responding to already old data, because even if there's a delay of 24 hours or 2 days, 3 days in the information that government is able to process, it means that they're constantly reacting too late, because of course the pandemic was developing so fast. I don't know enough about the specific case of South Africa, unfortunately, but it's an interesting question. Then there's a question about how much machine learning is currently being used in public policy, in the policy space in South Africa presently. suggestions around specific areas. To my knowledge, not very much, and we are just about to start a research project specifically in that to understand how much and where technology and data science is currently being used in the public sector in South Africa. Generally speaking, I would say, and this is not based on South Africa, but globally, comparatively, there's a lot more talk about data science in public policy and actual applications of data science to public policy. There are several reasons for that, but the way I see it, the main reason is simply because governments or government departments don't have the right skills, okay? There's an awareness that this is important and there's a lot of potential here, but they don't have the in-house capacity to actually implement data science or data-driven solutions. So it really speaks to the question of, you know, do we equip the future generation of public policymakers and public servants to take advantage of this? I would say currently not. And this is, but this is based on my personal perception. Then there's a last question: if there's an appetite in government to use data science in public policy, given the privacy concerns regarding use of people's data. Again, I think yes and no. My impression is that yes, again, there's an acknowledgement that this is important and has massive potential, but probably the most dominant public discourse right now is around privacy. And that discourse has forced us to adopt privacy measures that I personally find unnecessary. So the standard, the sort of standard policy response to privacy concerns has been like, you can't share anything, you can't collect anything, you can't do this, and you have to aggregate everything at the highest level. So that addresses the policy, the privacy concern, but it also limits what we can do with data. If we're not allowed to collect data, we're not allowed to share data, we're not allowed to integrate data, we are not allowed to do anything, we can't really learn from data. And I think that we need to come up with alternative solutions to addressing privacy concerns. That, you know, there are ways of addressing it, also using sort of algorithms, okay? We can use algorithms to introduce noise in the data, a randomness factor. That means nobody will be compromised, no individual will be compromised. But because of this randomness factor, we can still use the data to address, to understand, to learn from, to take decisions. But this is a more, again, it requires data science skills that I think often public policymakers or public servants don't necessarily have. So the sort of immediate reaction is just it's a legalistic, it's a legal response to an issue rather than a scientific response to an issue, if that makes sense. I think that's it. Again, I apologize for taking this long. As you can perhaps say, I'm very passionate about this, and I was hoping we could have a discussion about it. But yeah, please, if you're interested in learning more, please get in touch. I'm always interested in engaging with people who have similar interests. So feel free to get in touch, and if you have questions or would like to discuss more. So thank you for your time. It was longer than it was. An hour and 10 minutes. So apologies for that, and thanks for your patience. All the best. Thank you.